tend to assume that smarter foundation models naturally lead to safer, more reliable autonomous agents. But an agentic system does not become governable simply because it uses a better model. Intelligence is not the same thing as control. Standard safety measures, like prompt engineering, red teaming, and model alignment, are designed to shape a model's outputs. They do not provide structural guarantees when an agent is deployed into a live production environment to make independent decisions. In conventional software, much of the control is buried inside procedural logic, hard-coded steps that say, first do this, then do that. For autonomous systems, buried logic is insufficient. When an agent is free to interpret and coordinate tasks, its constraints need to be explicit and reviewable. Governability is a structural engineering property, distinct from the underlying intelligence of the model. To achieve this structure, the exact conditions of agency, what the system is allowed to do and why, must be explicitly defined before execution ever begins. Then, those defined conditions must be continuously observed, checked, and actively enforced the moment the system goes live. Responsible autonomy requires a permanent architectural split. We must separate the definition of allowed behavior from the operational machinery that enforces it. This split is formalized in the 7+5 framework for governed agency. The first half of this framework is governance as design. This acts as a strict boundary contract. It establishes exactly what the system is allowed to be and what rules it must follow before it ever interacts with a live environment. The second half is governance as infrastructure. This is the live operational machinery. Its sole purpose is to keep active execution strictly contained within the design contract established on the left. Design without runtime enforcement is purely theoretical, well described but weakly enforced. Runtime enforcement without design limits is conceptually ungrounded, operating without clear limits. Enterprise organizations can scale agentic systems safely by decoupling these two concepts, establishing design boundaries first and deploying runtime machinery to enforce them second. Governance as design is built on the 7 declarative intents. These are inspectable, portable constraints. They do not describe step-by-step logic. They state the conditions that must remain true, regardless of how the agent executes a task. The first intent is exactly that, intent. This defines the specific business purpose and the expected outcome the agent exists to achieve. Without it, there is no way to judge correct behavior against mere possibility. Next is authority. This draws the explicit line separating the decisions an agent can make autonomously from those that require human escalation and approval. A model's technical capability to execute a task does not give it the authority to do so. An agent may know how to issue a refund, but it must be explicitly authorized to execute it. Third is policy. These are the machine-checkable rules and obligations that dictate admissibility. They establish exactly what must be true before any action is taken. Fourth is scope. This imposes hard containment limits on the agent's domain reach, specifying exactly which data, systems, and workflows are out of bounds. Failing to explicitly declare intent, authority, policy, and scope leads to mission drift. The system will expand from assisting to deciding, and from deciding to acting, reinterpreting its goals whenever it encounters a new adjacent opportunity. To prevent the agent and the control plane from misinterpreting each other, the architecture requires a fifth intent, meaning. Meaning establishes the semantic ground rules. It requires canonical definitions and ontologies so that events, states, and categories are interpreted identically across every component of the system. The sixth intent is proof. These are the immutable evidentiary obligations required to verify decisions. If a decision cannot be evidenced later, it cannot be audited or challenged. Finally, effects. This constraint defines the allowed real-world consequences an agent can trigger, such as database writes, financial transactions, or external system calls. Effects represent the exact threshold where theoretical model risk becomes an operational business consequence. Together, these 7 declarative intents completely define the boundary contract of agency. They answer exactly what the system is allowed to be, long before execution begins. A defined boundary is useless if it is never actively tested against live conditions. Real systems operate under uncertainty and pressure. This requires governance as infrastructure, built on the 5 runtime controls. This is the operational machinery that answers what is happening right now and enforces the design contract in real time. The first control is monitoring. This is the sensing layer. It provides continuous observation of system telemetry, model confidence markers, latency, and side effects. Without continuous monitoring, the system runs blind. Governance is reduced to observing damage only after it has already occurred. The second control is threshold enforcement. This is the automated mechanism that evaluates live operational conditions against predefined limits, instantly restricting flow or pausing execution when a boundary is breached. Threshold enforcement is the engineering bridge that renders static organizational policies as live executable logic. Real-world agentic systems inevitably encounter broken dependencies, invalid transitions, and high degrees of ambiguity. Execution rarely stays on the happy path. The third control, exception management, handles these deviations. It provides a governed response to unexpected conditions, preventing the system from resorting to silent failures or unsafe improvisation. The fourth control is escalation pathways. When an agent reaches the edge of its defined authority, this deterministic routing moves ownership upward to the correct person, role, or team. Autonomy without defined escalation pathways is brittle. When a system does not know how to hand over control, it will either stall completely or dangerously overreach. The final control is runtime supervision. This is the ultimate command layer, giving human operators the active capability to pause, isolate, override, or terminate execution at any moment. Collectively, these 5 mechanisms preserve human responsibility. They ensure the agent remains fully controllable, even under extreme operational uncertainty. The 7 intents and the 5 controls are not isolated frameworks. They are 2 interconnected halves of a single governed system. Static boundaries map directly to dynamic responses. Authority relies on escalation pathways to route decisions. Policy relies on threshold enforcement to activate rules. Scope relies on runtime supervision to block unauthorized expansion. And allowed effects rely on both to secure limits around real-world actions. This explicit architectural mapping ensures that every theoretical organizational constraint has a direct executable enforcement mechanism operating in live production. Agentic governance cannot be treated as an afterthought. It is not an oversight layer added after capability is achieved. True governance must be built into the system twice, first as a design time contract, and second as a runtime enforcement infrastructure. Implementing the 7+5 framework provides the structural foundation required for responsible, enterprise-grade autonomy.